wonderful learning individuals. It is a pleasure. How are you all doing today? It is so great to have you. Thank you also so much for pressing the play button. I'm Johnny, your host with HomeCountry Mathematics. Please feel free to stay to also learn, because you know, mathematics can really be fun. Now, let us learn some math together, shall we? Alright, guys and gals, it's great to have you. Thank you for following along and watching the content. You know I appreciate you. Alright, we are continuing on with Unit A, Section 1-2, in the area of adding and subtracting rational numbers, because they're rational. I don't know if that was funny or not, but I threw that in there anyways. Alright, let me clean things up here. We're gonna work on some more problems. I decided to keep my little number line grid here so that I'm not having to redraw it all the time. Let's work on some problems for fun. Okay. Negative 11 plus a negative 7. If you've been following along so far, you'll already understand which direction we're going to be going and what values or signs that we're going to have. Okay, imaginary 1, we end up with negative 11, negative 7. Okay, I explained the imaginary 1 in the 2 prior videos, so I do recommend you check out that content. Again, it's great to have you. Alright, so that means we have same signs, therefore we're going to be kind of adding, but we're adding in the negative direction. I know it kind of sounds silly to say adding, but when we think adding, we're increasing, right? Technically speaking, we are increasing, but in a different direction, the negative direction. Simple math, what's 11 plus 7? You could do that, right? You know that positive 11 plus 7. You know that answer. Again, same signs, right? Because they're the same signs, we have positive 18. Same signs, our answer is going to be negative 18. Math is really, the integers are really easy once you understand the signs concept, okay? That's that. All right, let's clean some of this up. Looks like we have a fractions one here to do. I'm wondering if I have the room to do this, but we're going to do this. Okay, same logical concepts. We have 7/8 or 16ths, my apologies, plus, and then brackets, big brackets, a negative. And as a matter of fact, I prefer to put the negative up with the numerator. That's just a habit I've created over the years grinding enough math problems. Just as you know, when you're working with adding, subtracting fractions, you know that all the work happens in the numerator, right? Okay, same concept. It's no different, guys and gals. We have an imaginary 1 there. So mathematically, what is happening here is we have a plus 1 times a negative 3/8. Okay, it's imaginary 1. we still need to do the same typical common denominator stuff. So essentially, if I get rid of the plus sign, I'm just going to rewrite this. We have negative 3/8. Okay? The negative still belongs to the numerator of the 3/8. Again, whatever's to the right of the sign has ownership. Okay? Whatever's to the right of the sign has ownership. All right, I'm going to go with 16 as my common denominator. Let me do this. I'm going to get rid of that just to give me some more room here. All right. And I'm going to bring it up here. Okay? So we have equals. Equals. Everything's going to be over 16. I recommend you follow my fractions series so that you have a better understanding how to do fractions. I go through a lot of examples and explanation, okay, to help you guys and gals out. All right, 7 is unchanged. Subtraction sign. We have 2 times 3, which is 6. Okay. 7 take away 6 is, because this is a positive, that means our answer is also going to be a positive. That's why, again, I've been trying to teach you guys and gals to have that understanding that this sign belongs to the 6. So technically it's a negative 6 and this is a positive 7, right? So 7 is the bigger number. If we're ignoring the signs, we know that we're going to have more jumps, right? So we're actually going negative 6 jumps, which is going to take us to positive 1, right? Negative 6 jumps. Positive 1. Actually, we don't need that. Okay, so we have 1 over 16. All right, perfect. Let's do another. Again, if you think about it, fractions, just like decimals, fall in between these ranges, right? It's no different, guys and gals. Okay, we can have fractions in between, wherever 7/8 would fall in here somewhere, just over half, right? These 7/8. Same logic, right? We could turn it to a decimal, 0.875. It's all the same, right? Matter of fact, I'm just going to leave that there. All right, 18, subtract 23. Okay, this is algebra, guys and gals. Follow these basic rules. Just remember, any whole number that is to the right of the sign has ownership of the sign. So therefore, our 23 is actually a negative 23. Okay? Now looking at the whole number, we know that logically, just ignoring the signs, we know logically that the number 23 is greater than 18. Therefore, we're going to have more jumps with the negative, right? With the 23. 23 obviously is greater, more jumps, right? That's kind of the logic I'm trying to teach here. Therefore, with that logic and understanding, this means that our final answer is also going to be a negative. Okay? So in the sense we're doing, because they're different signs, right? So technically we're subtracting, if you want to kind of look at it like that. That means we're going to have a smaller number, not a bigger number. You only get bigger numbers if the signs are the same. It doesn't matter if they're both negative, and it doesn't matter if they're both positive. Right? If you have two positive or two negatives, your number is going to increase. It's the same thing, right? Both signs are positive, we're going to increase. Okay, that's just a quick example for you. Okay, you can see that. It's just direction, that's all it is. It's a matter of direction. We're going right is a direction, left is a direction. Are you driving north or are you driving south? Are you driving east or are you driving west, right? Okay, so I could just simply do simple math here. All I have to do is go 23 subtract 18, just ignoring the signs. I know I'm going to have a smaller number. I already know my answer is going to be negative. I already know. Okay, but I can still do this simple math here. I'm going to make that 1, that's 13. 8, 9, 10, 11, 12, 13, that's 5 jumps, right? Or a difference of 5. So our answer is going to be a negative 5. Let me clean that up. Negative 5. And a quick check mark. Boom. You understand? I hope that helps. I'm going to do more examples, and I'll do my best to keep repeating myself just to kind of help you store it in memory, right? Okay, here we go. So now they have one here with decimals. I was kind of hoping we'd just do whole numbers, but I mean, it's all the same. I could actually write, they have 32.25. As we all know, 1/4 is equal to 0.25. So I could write it in a fraction form, which is 32.25, right? I could. Again, it's up to you if you prefer to subtract with decimals or if you prefer to subtract with fractions. It's kind of up to you. Logically, as long as you do the work correctly, you should have the right answer. Okay, this is a good one, because now I'm going to show you a new math rule. Okay, a new math rule. Check this out. This time we have this sign here, right? Okay, with the same logic. This 32.25 owns this negative. It has ownership, okay? Any value to the right of a sign has ownership of the sign to the left of it, okay? Remember that. Okay, this is just our subtraction sign, but we also we have a negative inside of brackets. Okay, and this is going to be 32.5. Here's another new math rule. Okay, the first math rule was a negative. Let me start again. I could go 1, I guess. I wish I could write better. I wish I had a pen. Okay, a positive times. I'm just gonna actually use a dot. Positive times a negative equals a negative. It doesn't matter if it's a decimal or a whole number. This is just for the signs, okay? For the signs. It's signs math. Signs math. Okay? Now here we have a negative, right? Remember, it's still the imaginary 1 concept. That doesn't change. What's happening here mathematically is we have a negative 1 times a negative 42.5. Okay? Here's the new rule. Rule number 2. A negative times a negative equals positive. I recommend that you kind of just run this through your mind a whole bunch of times, right? For memory's sake. A positive times a negative equals negative. A negative times a negative equals positive. When you go to do your exam or test, whether you're in school, again, I'm here to help you, all you students that need extra help, and all parents, okay? All right, here to help. That's my goal, is to help you. I want to do something positive for the world, and that's what I'm trying to do here. Again, it's great to have you. Okay, a negative times a negative equals positive. All right, I'm just going to do this, so I'm going to go like this. A negative 32.25 plus, I'm changing the sign. Right, the negatives kind of cancel, essentially, and become a positive. Okay, now here's the logic, right? So looking at the two values, just ignore the signs, just ignore them. We can clearly see that 42.5 is the bigger number. It's the larger number, right? 42.5 is greater than 32.25. Correct? Again, it's the same logic. The sign, okay, the decimal or the whole number, whatever it is, could be anything. Whatever's to the right of this sign has ownership. So the 42.5 owns that sign, which means this 42.5 is a positive value. Okay? Because it's greater, that means our answer is going to be positive. Make sense? So we're basically just straight subtracting because the signs are different. If you know the sign ahead of time, you could just simply do your subtraction. Because the signs are different, we could do the subtraction. 32.25. Hopefully I have the room here. Should have maybe raised it up, but again, because the signs are different, we're getting a smaller number, right? Borrowing, I'm going to make this a 4. That's 10, that's 5. This is 2. That's 0. This is 1. So we should have 10.25. A positive 10.25. Oh, I love this, guys, gals. I love this so much. Math is great because it's good for your brain, and when you get older, you can do this when you're older. Again, enjoy your youth. I'll tell you that much. Make good decisions in life. I recommend that. And always be part of the people that actually care about you. Be close to them, okay? And fulfill your dreams and goals and make good decisions. And then when you get older, you can do this math because it's fun and it's good for your brain, okay? Math is good for your brain.
Wild, you either have bear skin,
what?
Or you
okay,
have no skin.
Bro. Commercial. Get skipped. I like the commercial though. It's clothing. Okay, guys and gals, that is it. It is great to have you. Thank you for learning along. I am Johnny. I'll see you guys and gals in the next video. Again, every individual that is watching and learning along, we all support you. Good luck in your studies and good job. Take care for now.